All right, let's dive right in. We're about to go on a journey to the very edges of reality. In this explainer, we're going to try and wrap our heads around a concept that is honestly almost impossible to imagine: the true, mind-boggling scale of the universe. You know, it's a question that has captivated humanity for, well, forever. You look up at the night sky, you feel that sense of awe, but what are we actually looking at? Today, we're going to dig into some facts that will, I promise, completely change the way you see space.
So, to understand the size of the universe, we first have to understand its story. Where did it all come from, and just how old is it?
And this is a really profound idea when you stop and think about it. The universe isn't just eternal. It's not static. It actually had a starting point, a single moment where everything we see today began. And we actually have a number for that beginning. 13.8 billion years. Just try to wrap your head around that. Our entire recorded human history, it's like a tiny, tiny fraction of a second in the grand cosmic year. It's just unbelievable.
And the most important part? That story didn't just stop at the beginning. The universe is constantly changing. It's evolving. It's expanding every single second, getting bigger and bigger.
And the name we have for that expansion? It's the Big Bang Theory. But here's the thing. It's not an explosion in space, like you might picture. It was the expansion of space itself, from a point so hot and so dense it's just unimaginable.
Okay, so we've got a universe that's almost 14 billion years old, and it's always growing. But what's actually in it? Let's start filling in this vast cosmic canvas.
This is honestly one of my favorite facts in all of science. I want you to picture every beach, every desert, every single grain of sand on the entire planet Earth. Got it? Well, there are more stars in the universe than that. Way more. It's a number so big, it's kind of hard to even process.
And all those stars, they're not just floating around randomly. Nope. Gravity pulls them together into these enormous, beautiful, swirling structures that we call galaxies. You can think of each one as a city of stars.
So how many of these cosmic cities are out there? Well, scientists estimate, get this, over 2 trillion galaxies in just the part of the universe we can see. 2 trillion. And each of those galaxies has billions, sometimes trillions of its own stars. The scale is it's staggering.
Okay, let's bring it back home for a second. Our solar system, our sun, and us, right here on Earth, we live inside one of these incredible structures. Our home address, cosmically speaking, is the Milky Way galaxy. And speaking of our sun, we tend to think of it as huge, right? But in the grand scheme of things, it's kind of average. Just look at this. The biggest star we know of, UI Scuti, is so gigantic that if you swapped it with our sun, it would swallow up Earth, Mars, Jupiter. It would reach all the way out to Saturn. It's just massive. So we have these gigantic stars. But what happens when they die? Well, their death can create some of the most extreme, most dense, and frankly, most bizarre objects the universe has to offer. Let's get weird. So what happens when matter gets crushed down to its absolute physical limit? I mean, imagine taking something much, much bigger than our sun and squishing it all down into a space about the size of a city. What you get is something truly extraordinary. You get something called a neutron star. And the density is it's off the charts. We're talking about the densest stuff you can actually observe in the entire universe. So dense that if you could somehow scoop up a single teaspoon of it, that little teaspoon would weigh 6 billion tons. I mean, think about that. That's like taking 900 Great Pyramids of Giza and cramming them all into a single spoon. It is absolutely mind-bending. Okay, so a neutron star is matter pushed to its absolute breaking point. But what if gravity just keeps on winning? What happens when it becomes completely, totally unstoppable? Well, that's when you get a black hole. And it's not an empty space. That's a common misconception. It's an unbelievable amount of stuff packed into a tiny, tiny area. The gravity is so intense that it basically breaks the rules. It creates a one-way door in the fabric of space-time. Nothing, not even light, can escape once it crosses that line. Okay, so we've talked about age, about all the stuff in the universe, and about some seriously dense objects. But for our final section, let's try to get back to that original question. Just how big is it? How do you even begin to measure something so ridiculously vast?
Well, our usual rulers, like miles or kilometers, they're completely useless at this scale. So astronomers had to come up with a new yardstick, and they decided to use the fastest thing in the entire universe, light.
So to give you an idea of how fast that is, let's just start with our own neighborhood. The light from our sun takes about 8 minutes to travel all the way to Earth. That means when you look at the sun, with proper protection of course, you're actually seeing it as it was 8 minutes in the past.
Okay, got that? 8 minutes. Now, I want you to imagine a beam of light just going. Not for minutes, not for days, not even for thousands of years. Imagine it traveling, uninterrupted, for billions of years. And if you do that, you eventually get to this. The diameter of the part of the universe that we can see, and that's a key word, observable, is estimated to be about 93 billion light-years across. The light from the most distant things we can detect has been traveling for almost the entire age of the universe just to get to our telescopes. And that brings us to the final, really chilling thought. That colossal 93 billion light-year number, that's just the part we can see, the part where light has had enough time to reach us. So it leaves us with the ultimate question. What lies beyond that edge? What's out there, past the horizon of what we can even observe? And that, right there, is the mystery that keeps us looking up.